Today, I'm going to show you step by step how to do a stoichiometry problem when you're given your amounts in mass units. We are going to do the stoichiometry problem by using conversion factors. So let's go ahead and look at an example problem. Here is our sample problem. If you start with 5.5 grams of sodium fluoride, how many grams of magnesium fluoride will be produced? Now, the first thing I like to do with a stoichiometry problem like this is to go ahead and make notes above my chemical equation so that I can keep track of what I'm trying to do and what information I've been given. So let's read the question again slowly. If you start with 5.5 grams of sodium fluoride, so I'm going to go ahead and write 5.5 grams right above sodium fluoride so I can remember that's how much I have of that particular compound. The question is, how many grams of magnesium fluoride will be produced? So I'm going to put a little question mark above the magnesium fluoride to help me remember that is what I'm trying to solve. Okay, so now we're ready to start our actual stoichiometry problem. So I am going to write down a list of steps that we can refer to that will help us keep track of what we need to do to solve the problem. So first on our list is we need to use a complete balanced equation. Remember, as we talked about earlier, you must always use a balanced chemical equation when you're doing stoichiometry. If you don't, you will not get the right answer. So let's look at the chemical equation we were given and double check that it's balanced. We have 1 atom of magnesium on the left, 1 atom of magnesium on the right, 2 atoms of sodium on the left, 2 atoms of sodium on the right, 2 atoms of fluorine on the left, and 2 atoms of fluorine on the right. So our equation is balanced, so I'm going to check that off. The next thing we need to do is convert any amounts that are given in mass units to moles. Again, remember, the coefficients in a chemical equation tell you the relationship in moles between the different compounds. They do not tell you the relationship in terms of grams or pounds or a mass unit. So it is very important that when you're given the amount in a mass unit, like we are in this problem, that you remember to convert it to moles. This is a typical problem that lots of students have. It's easy to forget to do this step, so please remember to always convert your grams to moles. So we need to convert our 5.5 grams of sodium fluoride to moles. So as we did earlier in the semester, we talked about how to convert grams to moles. We need to add up the molecular weight of sodium fluoride. So sodium fluoride has 1 atom of sodium, 1 atom of fluoride. We go to the periodic table to find the molecular weight of each of these elements. Remember that the number underneath the element symbol is the molecular weight. So the molecular weight of sodium is 22.99. The molecular weight of fluorine is 19. We have only 1 atom of each, so we add that up. And we have just calculated that the molecular weight of sodium fluoride is 41.99 grams per mole. We can now use that to convert our amount in mass to grams. We have 5.5 grams of sodium fluoride. We will write our conversion factor, 41.99 grams in 1 mole of sodium fluoride. And I want to take the time here to point out you should always write your units when doing stoichiometry problems. There's a lot of math going on, a lot of multiplying, a lot of dividing, and it's really easy to maybe flip something upside down. But if you write your units out and you make sure that your units cancel out, just like it's written here, we can see that our grams cancel out because you know you wrote your conversion factor the right way. So please take the time to write your units out. It will help you keep on track. So now that we've set our problem up, we take 5.5, divide by 41.99, and we have found out that we have 0.13 moles of sodium fluoride. So remember, 5.5 grams is equivalent to 0.13 moles. It's essentially the same thing. So I'm going to go ahead and write this up here in above our equation so we can remember what information we have. So we now know we're starting with 0.13 moles of sodium fluoride, and we are now going to figure out how much magnesium fluoride will be produced. So I'm going to cross that off of our steps to complete because we have finished doing that.
That's good.
Okay, next on our list is we need to write a conversion factor that we can use to convert from moles of one compound in the equation to moles of the other compound. So we are wanting to look at the relationship between sodium fluoride and magnesium fluoride. Remember that you use the coefficients or the numbers in front of the compounds to write this relationship. So there are two conversion factors we could write. There's a 2 in front of the sodium fluoride. So we know that for every 2 moles of sodium fluoride that we start with, we will produce 1 mole of magnesium fluoride. Remember, if there is no coefficient in front of a compound, you can assume that the number is 1. So let's write that down. 1 mole of magnesium fluoride. And again, we can write these conversion factors either way. So we will also write the inverse. 1 mole of magnesium fluoride will be produced for every 2 moles of sodium fluoride that we start with. Okay, so now we have our conversion factors that we can reference. Next, we want to actually complete the calculation using the conversion factor. So let's start by writing down what we were given. We know we're starting with 0.13 moles of sodium fluoride. We now know we need to multiply by one of these conversion factors. And again, because we took the time to write our units, it's easier for us to know which conversion factor to use. We need to use this second conversion factor because it has moles of sodium fluoride in the denominator. Because again, we always want our units to cancel out. So we're going to use the second conversion factor, which is 1 mole magnesium fluoride over 2 moles of sodium fluoride. So our moles of sodium fluoride cancel out. And we can see that we've set up our math. We do 0.13 divided by 2, and we will end up with 0.065 moles of magnesium fluoride. So we have just completed our calculation using the conversion factor. And we figured out 0.065 moles of magnesium fluoride will be produced. Are we finished with this question? Let's check. Let's reread the question. It says how many grams of magnesium fluoride will be produced. We just figured out how many moles. So we're not quite finished. We have one more step. We completed the calculation using the conversion factor. We can check that off. But now we need to convert the amounts calculated in moles back into units of grams. So we'll do that last real quick. So we just calculated that we will produce 0.065 moles of magnesium fluoride. Let's go ahead and write that up on above our chemical equation. And we will now convert that amount into grams. All right, so the last step that we're doing is we're converting our 0.065 moles of magnesium fluoride into grams. We're going to do this the same way we converted from grams to moles earlier. We need to add up the molecular weight of magnesium fluoride. Magnesium fluoride has 1 atom of magnesium, 2 atoms of fluoride. We can look at the periodic table. Magnesium has a molecular weight of 24.31 grams per mole. Fluoride has a mass of 19 grams per mole. Again, we have 2 atoms of fluorine, so we need to multiply 19 by 2 to take into account both atoms. So we can multiply that out. 2 times 19 is 38. We have only 1 atom of magnesium. We can add those up. and we have found the molecular weight is 62.31 grams per mole. So now we're ready to convert our amount in moles back to grams. We have 0.065 moles of magnesium fluoride. We're going to multiply by our conversion factor. 1 mole of magnesium fluoride weighs 62.31 grams. Again, because we wrote out our units, we are positive that we should be multiplying by 62.31 and not dividing because our units cancel out. So now we can take out our calculator. 0.065 times 62.31, we get 4.05015 grams. And like we learned earlier in the class, we now can round our answer. We don't need all these digits here. We started the question with 2 significant figures, so we will round this answer to 2 significant figures. So we're going to round to the 10th place. So we're going to say we have 4.1 grams of magnesium fluoride. So there you have it. We did mass-to-mass stoichiometry and figured out our answer. That's it.